This video is for this practice packet that Mr. Pitchker and I gave. So I'm taking a look at number 1. If I directly substitute in -2, I get 0 in the numerator, right? And then in the denominator I get 0. So I'm in 0 over 0 form. Okay, that is called indeterminate form. I'm going to show you L'Hopital's rule because I don't think you were able to quite fit this topic in last year. So the way L'Hopital's rule works is you have to get the derivative of the numerator and the derivative of the denominator separately. So when if I call the numerator f of x, then f prime of x is -3. If I call the denominator g of x, then g prime of x is 2x plus 1. So now if I try to get this limit, right, so if I get the limit as x approaches -2 of f prime of x over g prime of x, that's L'Hopital's rule, because the 0 over 0 is called indeterminate form. So now I have the limit as x approaches -2 of -3 over 2x plus 1. Now if I take -2 and substitute it into here, I get -3 over -3, which is 1. All right. Now, we're going to take a look, okay, at this next question. I'm trying to get this, oh, there we go. I wanted to get that pen out of here. So in the next question, they give you this graph, and they want to know which of the following statements is true. So let's analyze each one. So if we're approaching 1 from the left, let's take a look at approaching 1 from the left. So here you are approaching +1 from the left. So as you're traveling toward 1 from the left, you are heading toward 3, okay? So this is 3. So it exists. You don't have to have a value for f of x, okay? F of x, you can see there's a hole, so f of x does not exist at 3. Now I'm going to travel toward the 1 from the right. So here I go, traveling toward 1 from the right. That right-hand limit is still 3. So then they're asking us, well, does the limit as x approaches 1 exist? And the answer is yes, because when the left-hand limit and the right-hand limit are equal, the limit does exist, and it's 3. So the answer is all 3 of these. Let's take a look at number 3. So number 3, I'm given this piecewise function, and they ask me which of the following statements are true. All right, so first off, the function's value at 3 is the square root of 3x. We don't use that function when we're getting the limits. We use the value of the function as you're heading toward 3. So we would use this function, okay, as we're heading toward 3. So let's get the limit as x approaches 3 from the left, which is going to be the same as the limit as x approaches 3 from the right here, because we're using the same function and we're substituting in 3. So I hope that's common sense. So if I directly substitute in 3, I get 9 minus 18 plus 9. So I'm in 0 over 0 form. So I have to use L'Hopital's rule. So I get the derivative of the numerator. So what do I get? 2x minus 6. The derivative of the denominator is just 1. So the limit as x approaches 3 is 2 times 3 minus 6, or 0. Now, as far as the value of f of 3, I would have to substitute to figure out this, so this checks. To figure out this, I would have to substitute into square root of 3x. So let's try it. Square root of 3 times 3 is indeed just the square root of 9, or just 3, right? So that exists, check. But it's not continuous, because the definition of continuity is that the limit as x approaches 3 of f of x would have to literally equal f of 3. But they don't equal one another. 1 equals 0, 1 equals 3. So the answer would be 1 and 2 only. Okay, let me scroll down. So number 8, what seems weird about that? 1, 2, 3. Huh. Somehow it just jumps to 8. Okay. So for number 8, we have f of negative 2 equaling 4, and then we have the derivative at negative 2 equaling negative 1. And then they ask us to find the derivative of this function they gave us at x equals negative 2, right? So let's use the quotient rule. So we have low times d high minus high d low over low low. So now I need to substitute in negative 2. So I get 4 times f prime of negative 2. Well, that's negative 1. Minus f of negative 2, which is 4, times negative 4, over negative 2 to the 4th power is 16. So now I have negative 4 plus 16 over 16. Well, that's 12 over 16, which is 3/4. So that's all you have to do for that. Taking a look at number 9, I think we had a very similar question on the last practice. So in order to get this, number 1, you have to get secant of pi over 4. So secant is the reciprocal function of cosine, right? So we would have 1 over cosine of pi over 4. I almost started writing the value. I didn't know if that would confuse you. So I have 1 over square root of 2 over 2, which you know is 2 over square root of 2. And if you rationalize that, it's 2 rad 2 over 2, which is just rad 2. Right? So what I did is I multiplied by square root of 2 over square root of 2. So now I have to get my slope. So y prime is secant tangent. Now I have to substitute in pi over 4. So what do we get? We get secant pi over 4, right? Well, we already know that that's square root of 2. Tangent pi over 4, well, we know that's 1, because it's sine divided by cosine. So the final answer would be y minus square root of 2, because that's y1 equals square root of 2, that's the slope, times x minus pi over 4. All right, I'm just looking at which choice that is. So that is choice B. All right, that's the tangent line. Let's take a look at number 10. For how many values of x are the tangent lines to these two curves parallel? Well, if the tangent lines are parallel, right, that means their slopes are equal, which means their derivatives are equal. So we could set their derivatives equal. And then you could take out a calculator, put it on your calculator, make sure you're in radian mode, graph it, and see where they intersect. So I have y prime is cosine x minus sine x. And then the other y prime, I have 3x squared over 12 minus 2x over 2 minus 1/4. So I have cosine x minus sine x equals x squared over 4 minus x minus 1/4. I'm going to pause and I'm going to type that into my calculator and see how many intersections. So I graphed it and I only got one intersection. It was 6.1 something. You do need to practice with your window. So for my window, I made my x min -5, my x max 8. I made my y min -3, my y max 3. It appeared like there were two intersections at first, but then I zoomed in on the one point where I thought there would be an intersection, which was around two-ish, and there wasn't. So there you have it. Okay. All right, we have continuity and differentiability. So I'm taking a look at number 14, and they want to know about being continuous and differentiable. Okay, first I have to get the right-hand limit and the left-hand limit and see if the limit exists. So as I'm approaching f of x from the left, which function do we use? So we're approaching 3. I think I said f of x. From the left of 3 is what I meant. So from the left of 3, we use x minus 1, right? So that's just 2. When I get the limit, as x approaches 3 from the right-hand limit, we're going to get 3 squared, okay, which is 9, minus 15, plus 8, which is also 2. 17 minus 15. Okay, so the limit exists. Now, is it continuous? Well, if it's continuous, you go to where it would equal 3 and substitute it in, which we've actually already done, and get 2. So, yes, the limit as x approaches 3 exists. We know that. It's 2. But f of x, f of 3 is also 2, so it's continuous. Now, differentiability, you have to get the derivative. So I get 2x minus 5. And then I get 1. So if I'm approaching from either left or the right, I get 1 for both of these. Okay, therefore the derivative is continuous, so it's differentiable. So I get 1, 2, and 3. Let's take a look at number 15. All right, Matthew is visiting at his home on North Street. Oh, visiting Gregory. Shortly after Matthew leaves, Gregory realizes that Matthew left his wallet, and Gregory begins to chase him. When Gregory is 3 miles, so this is the picture of where Gregory is. So this is the when you're doing related rates. So when he's 3 miles from the 90-degree intersection along North Street, traveling at 45 miles per hour towards the intersection. By the way, that's negative because he's traveling downward, okay? So the rate, we'll call this x. So when x equals 3, we have dx dt is negative 45. Matthew is 4 miles, so y is 4. Traveling away from the intersection at 30 miles per hour. So that's dy dt is 30. At that time, how fast is the distance between the two men? Well, look at the distance between the two men, right? So that would be the hypotenuse. So we need to relate x, y, and we'll call this z. So we have that right angle. We have the Pythagorean theorem. So we have x squared plus y squared is z squared. get the derivatives using your chain rule. Implicit differentiation here. Okay, so we're relating these rates. 2y, dy, dt. And then we have 2z, dz, dt. Okay, do you see that all the 2's can cancel out to make our lives easier? All right, we can divide everything through by that. Okay, so we're looking for this. This is what we're looking for. So you're probably wondering, okay, do we have to get z? Yeah, it's a 3, 4, 5 triple, so that makes life sweet. So we have x, right? So x, we said, was 3 times negative 45 plus y times 30 equals z times dz dt. So divide both sides by 5. So the 5 could just make this negative 9, right? And make this 6. So I'm just going to go 3 times negative 9, 4 times 6. All right, so I get negative 3, which means they're getting closer. So at 3 miles per hour. Let's take a look at number 16. A cylinder has both its height and radius changing, so it's getting wider and taller. Draw a picture of a cylinder. Its height, so the height, dh dt, is increasing at 3 meters per minute when the height is 8, the radius is 2. The volume is not changing. Well, if the volume is not changing, that means its rate would be 0. How fast is the radius decreasing? So we want to relate the radius to V and H. So we have the volume formula, pi r squared h. Okay, however, dv dt is going to be 0. Okay, I'm going to use the product rule here, so I get 2 pi r dr dt times h plus pi r squared dh dt. All right, so now I have to substitute that in, so I get 2 pi 2 dr dt is what we're looking for, times 8 plus pi times r squared, so I'll just write 4 times dh dt, 3. And so we're looking to solve for this, so it's going to be negative 12 pi divided by 432 pi. So those cancel out, and you have negative 12 divided by 32. So I could divide both of those by 4, right? So if I divide those by 4, I get negative 3 over 8. Now it already asked how fast it's decreasing. You can put the answer as 3/8 because they have the word decreasing. Decreasing means negative. Now kids have had problems with that on the AP exam, where they'll write decreasing at a rate of negative 3/8. No, in that case you would just say increasing at a rate of 3/8. So just be careful with that. When the word is there, you represent that number as a positive. In number 20, we have the graph of the derivative. Which of the following statements is not true? Not a fan of negative questions, so we're looking for wrong math. Okay, number 1. This is the graph of the derivative. Keep that in mind. So is f increasing from 2 to 4? Well, because the derivative is positive, it would be increasing. So that's not the answer because we're looking for something wrong, wrong math. Okay, f has a local min at 1. So if we go to 1, look at the derivative. Does the derivative change sign there? No, right? If you had a min, so picture a min on a graph of f. So if you had f and you had a min, the slope would be going from negative to positive. So that doesn't happen there. So there is no local min at 1. All right? So I'll just go through the others with you anyway. So if we go to 0, we have a local max because look at what's happening. Okay, the derivative is going from positive to negative. The derivative of f. So that would be wrong because it's right. Okay, an inflection point at 1. So an inflection point is where the slope of the slope changes sign. So the slope of the slope does indeed change sign here. Or you could say that f prime of x goes from decreasing to increasing. That's another way you could say there's an inflection point. Concave down. So from negative 2 to 1, the slope of the slope is negative, which means f double prime is negative, which means it's concave down. Okay, let's look at number 21. We have the graph of f of x. At what point is f of x increasing? I like to put this in layman's terms. So where is f of x increasing? And since it's greater than 0, concave up. Well, it's the graph of f of x is increasing and concave up right here, right? So it's increasing, concave up to here. Then it turns around to concave down. So that would be, I'm trying to read that number. It looks, are they just calling it b? I don't know if b stands for the y value or the x value. Well, I'm going to have to say that is not the greatest question. So the interval here would be, and it goes off to the left. So I'm just going to assume it's starting at 0. Okay, at what point is it increasing? Okay, increasing. So we can see it's increasing from A to B and concave up. And it's concave up. Okay, I think the wording's just a little bit off. A to B. Let's take a look at number 22. All right, so we have this graph and we want to describe the concavity. All right, number 1, okay, you always have an issue when you're dealing with n, with the different values of n, okay? So I'm just going to make a little chart here looking at these multiple choice questions, okay? Okay, so for number 22, I did the calculus for this question. So I got the first derivative and the second derivative. So the signs are always going to be positive when x is greater than 0, so it's always concave up. Now, if you just typed in those graphs, you would see, using those restrictions, that that's the same case as well. Okay, optimization. So we're looking for where this function has an absolute minimum. So what makes a function have an absolute minimum? Well, we have f prime of x equals 3x squared over 3 minus 2x. So that cancels. So I have x squared minus 2x. Let's look at when that's equal to 0. So we have these two critical points. Okay, we need to figure out the signs left and right of these to see if they are mins or maxes or what's going on. And well, we want an absolute minimum, right? So you can just do the candidate test instead. So the candidate test, or some people call it the closed interval test, whichever. You have to use the endpoints. So we have -2, 3, 0, 2. Okay, if you wanted to check if something wasn't a min, you could make a table for f prime of x and then not consider it a candidate, but you could also just put it in the table. They don't take off if you do that. Okay, but the function you're getting these values for f of x. So you need to get these 4 values and figure out where the absolute min is. All right, so it has an absolute min, as you can see, at -2, as shown by the candidate test. Okay, so number 27, we have the sum of 2 numbers is 12, so that's x plus y is 12. What is the maximum product? Okay, so we want to maximize this function. We need to get it down to 1 variable. So what I'm going to do is I'm going to take the y, is going to be easier to replace with an expression for x. I'm going to sub that in. So I have x cubed times 12 minus x. This is the function that I'm looking to maximize. So that's 12x cubed minus x to the 4th. So now you get the derivative. So I get 36x squared minus 4x cubed, setting it equal to 0, taking out the GCF. So I get 9 minus x. So I have 0 and 9. Okay, and we want to know what is the maximum product. Well, obviously 0 is not going to work out for us, guys. So we're going to take the 9. I'm going back to this equation here, which means that y is 3. So I have 9 cubed times the x value, which is 3. Okay, 9 cubed, I believe that's 729. Let me check my calculation. Okay, the wording is a little trippy in the last problem. So they're asking us where this function has a possible maximum slope. So we want to take the slope function and get its derivative. So number 1, I need to get the slope. So the slope function is 2x over 4, which is just x over 2. Okay. The 4 just comes along because it's 1/4. It's a constant. Plus 1 minus is going to become plus because cosine's derivative is negative, so negative. The 4 just comes along. Okay, you're going to have to use the chain rule, so I'm multiplying by 2 right now. Okay, so that cleans up to an 8. So now the derivative of the derivative is 1/2 plus, chain rule again, is going to be 16 cosine 2x. So, okay, so what do we want to know? So we want to know it has a possible maximum slope at the x value that solves this equation here, because we want to know maximum slope. All right, but I think I made a careless error here. Something seems awry. Hold on. All right, I reread this question. I'm still going along with the way I'm interpreting it. Okay, remember there's human error. So whomever put this question here, I believe they made a careless error, because we want to know where this function has a possible maximum slope. So the function whose maximum we're looking for is the slope. So when we do the candidate test, we'd be getting the derivative of the slope. So I'm still persistent that the answer would be 1/2 plus 16 cosine 2x equals 0. I'm sticking with that. Thank you.